Okay, so let's talk about behavior of the elements in the periodic table. We're going to start with the atom sizes. If we look as we go farther to the right in those periods, what we notice is that it's going to decrease as we go across. However, the size of the atom is increasing as we are going down. And the question becomes, why? Well, part of this has to do with the idea of these protons. The protons are going to attract the electrons. So as we are adding more protons and more electrons, as we are going across the periodic table, those protons are going to attract those electrons, making the atom tighter in. It's going to get kind of smaller in. So if we look at sodium and magnesium, magnesium has more stuff in it, but it has more protons and electrons. They both have 3 energy levels, but magnesium has a tighter pull on those electrons, so it's actually smaller since it has more protons. However, as we go down the periodic table, the atoms have more and more electrons, so the radius is going to be increasing because we're adding more energy rings to make rooms for more electrons. The atoms are going to get bigger. And then we need to look at the ionization energy. So this is going to be the energy that we need in order to remove an electron from an atom, and it's going to be measured in kilojoules or volts. And we have to think, what kind of atoms do you think are really tough enough to take an electron away from? Which ones do you think would be harder? Why do you think that some of them would be easy? So, if there is hardly any energy, it'd be easy to take it away. If there's a lot of energy in that outer level, it's going to be harder to take it away. So when we look at our ionization energy, it hardly takes any energy in order to take an electron from a metal. They want to just give them away. They don't have very many in their outer ring. They want to get as close to full as they can, and the quickest way is to slough those electrons off into something else. If we look at a non-metal, they don't want to give them away. They are close to 8, and they're like, just give me one more. And they'll be closer to 8. So it takes a lot of energy to try and pull an electron from a nonmetal. So if we look at ionization energy, it's going to increase as we move across the periodic table, because as we are going across the periodic table, the number of energy levels is not changing, but we have more protons. So that means the atoms are going to pull their electrons in tighter. They're closer to having 8 in their outside. Basically, they're going to make it a challenge. So sodium is going to have a lot less ionization energy. It's going to be a lot easier to ionize sodium than it is chlorine. Now, if I looked at sodium versus potassium, and apparently my rings have disappeared here, but humor me, which one do you think is going to have the lower ionization energy here? So if your electrons are farther out, it's going to take less energy to steal them. So potassium is going to be easier to steal from than sodium. So when I look at the ionization energy is going to increase as we move up the periodic table and as we move to the right on the periodic table. So when an atom takes or loses an electron, it becomes an ion. That means that the size may change. So metals are always losing electrons and becoming positive. Non-metals are gaining electrons and becoming negative. As we become positive, as we look at the metals, they're going to become smaller. You're losing entire energy levels. So you're going to become smaller. If we look at nonmetals, though, they become bigger when we give them electrons. Why do you think that is? Well, opposites attract, but we have the same number of protons that are pulling on more electrons. They can't pull on the electrons as well as they did. That leads to a larger atom size. So if we take two or more atoms or ions that have the exact same number of electrons, but they have different number of protons. So here we have the same number of electrons. We have 10 electrons. We have got all of this here. So we have different number of protons. So because they have the same number of electrons, we refer to that as isoelectric or isoelectric, depending on where you've heard the term. That means they have the same number of electrons. Now, which one do you think is the smallest? So pause here. Which one do you think is the smallest? If you said the one with the most protons, you would be right. So that means the one here on the far right is going to be the smallest one because it has the greatest attraction of protons to those same 10 electrons. So when we start talking about features of elements, electronegativity is something we have to talk about. Electronegativity, by definition, is the tendency to pull on an electron in a bond. So if I make table salt, sodium chloride, the sodium isn't really going to pull on those electrons. The chlorine is. So what kind of atoms do you think really pull on the electrons in the bond? What do you think aren't going to be pulling on those electrons? So the sodium, the metal, it's willing to slough it off. It's not going to be pulling on that electron. Chlorine wants to fill full, wants that full valence, it is going to pull a lot more. So when I look at electronegativity, what we're looking on is that tendency to pull. So we have electrons, they could be attracted to both nuclei, and we have that difference here. So those electronegativity, we can measure it. So sodium has a much lower electronegativity than chlorine. That means it's going to pull, chlorine is going to pull on that electron a lot harder. It's going to create a bond. We refer to that bond, it has a name, it's called an ionic bond. So nonmetals have high electronegativity values. Metals, low electronegativity values. If I looked at the trend of electronegativity values in a periodic table, it's going to look like this. So if I put all of this together, electronegativity, ion energy, atomic radius, into one chart, this is what it's going to look like. So as I go to the right, the radius is going to get smaller. The ionization energy and the electronegativity are going to increase. As I go down the periodic table, the atomic radius is going to get larger. The ionization energy decreases. The electronegativity decreases. That is our sum. So a lot of this is also summarized in the periodicity assignment that was posted, or note guide that was posted. So keep that in mind, read that, bring questions back.